All right. Never mind. Go back this way. So we talked a lot about networking, ports, sockets. I know there's a lot of material. It's hard to wrap your head around until you actually sit down and try to map some of these out. IP addresses, we're still going to use IPv4, I think, for a long time in the future internally. So IPv6 will be external to our network. IPv4 we're still going to use. We've got so much legacy infrastructure, and some things are just, because of the nature of that IPv4 address, I think it's easier for us to grasp and to wrap our heads around that I think we're going to see that for a while. In terms of security, though, IPv6 has a lot of advantages. So, kind of the last piece, or another piece in here, is the idea of that domain name service. And how do we translate then from google.com to a number, either IPv6 or IPv4? How do we translate that? So we know, and your brain knows, if I just gave you a list of numbers, they're pretty hard to remember. But I can remember words, and I can remember phrases, and I can remember clever websites. I can remember peru.edu. I can remember Google. I can remember whatever website for the most part. So there has to be a connection between the two of them. So when we look at a complete domain name, there's some pieces that come out of it that we need to look at. So a couple of things about domain names, just so we're kind of on the same page. They're registered with one of the internet naming authorities. So ICANN is the top level naming authority, and then they have smaller registries, and then finally they sell that naming authority back to a lot of companies. So if I go to GoDaddy, I can go get an email address or an address. If I go to Network Solutions, some of these others, I can do that. There are some restrictions on those addresses, not in the way that you think. I can put all the dirty words I want in an address, but what I have a restriction on is who can buy and purchase that rights to what we call the top-level domain. Top-level domain, weirdly, is at the end of your address. I know that seems weird, but it's that top level for you. So think about all the .peru.edu. All the edu addresses have a regulation. They have to be an educational institution. Now, are there some education institutions that are not legitimate? Sure. They're not to the level of policing where it has to be a good education institution, but for the most part, it restricts it. So things like .mil, you can't go out and buy a .mil address. You can't go buy a .edu without authority. You can't buy a .gov, and there's several others that have got some restrictions. .org has some restrictions on it that it should be a nonprofit organization. Now, I will say nonprofit organization does not mean legitimate, does not mean that the website has great content, and it doesn't mean that they're not making money somehow. So just be aware of that. But most anybody can go out and buy a .com or a .biz or a .us and some of these other addresses that are in there. So when we have this name, so we have peru.edu, we know it's an educational institution. We know that the name of it then is Peru, and it's been purchased by somebody in there. So some of them you've seen, .com, .edu, .gov, .org, .net. .net has gotten spread around a little bit, military, business, info. So one of the latest ones of the last couple of years that's come out and has sold a tremendous amount of addresses and registrations is this one, .xxx. But it's not. So you think XXX. What do we think content is on XXX? Not the kind you watch with your mother, right? But here's who's buying them. It's not the companies producing those kinds of videos and websites and things. It's other organizations that have a name similar. So UNL bought up UNL.xxx so that somebody wouldn't create a site that looked like their name. So that's where they've actually sold a ton of them. So, Nobody actually. So UNL bought them, and most companies. So like Ford would have bought it. Who creates? So that ICANN has ultimate authority over there, of who's got those top level domains. And they will sell. Yep. So they sell them to other companies to sell them. So like GoDaddy or whatever. If you go to GoDaddy, you can register. So for example, one of them I register for me is bradgriffinconsulting.com. I went to Network Solutions and I purchased that domain, so it's mine. I own that domain. And it goes through Network Solutions, who and then kicks back a little bit up to ICANN eventually. And they control who has that. So then if somebody else tries to register it, they go, oh, nope, that one's already registered. It's on our master list, and we can't sell that. But companies trying to protect their name, so, like, hey, I'm, cornflakes. I don't want to have cornflakes.xxx, so somebody put that out there and people get confused. And that kind of stemmed from many years ago. There was a site called whitehouse.com. And whitehouse.com was a hardcore pornography site. But how many school kids went whitehouse.com to try to go to? And so eventually they've reclaimed that, and now whitehouse.com actually directs to the whitehouse.gov site. But it's a matter of freedom, though. We really can't. So, it is. And so people are allowed to purchase anything literally they want to, and so it became an issue of how do we sell those. And the original intent was actually really good. It was going to move a lot of that kind of content, and it would be easier for filters and web scams and all this to cut that off if it were all .xxx, for example. But it has not worked exactly as planned, but there's always new ones coming out. Some of them, the vanity ones, you can get, so like .com.ca to go into Canada and different countries. So you'll see a lot of these top-level domains popping up as we go through there. So DNS is really at the top of our stack, and DNS says, all right, we need to come up with, you typed in whitehouse.gov, we'll use that one as an example, and we have to figure out what that address space lands as. So DNS is hierarchical. So in other words, it starts local. So it starts at our local computer, because our own computer can store some information if it's been there before. So if it knows whitehouse.gov is 172.something, it stops at your computer. If it doesn't, that information we're going to pull in that IP config where it says DNS servers, it asks that next DNS server up the line what that address is. So in this case, in this lab, our computer is going to ask itself, hey, do I know what this is? Nope. If it doesn't know, it asks my server in the back, which is working as a DNS server. If my server back there doesn't know what that address is, it moves into the campus of the school. So it kind of moves up that chain. Eventually end up at the top of this food chain. And at the very top of this food chain, there's 13 different servers. So ICANN essentially controls, in different companies around the world, there's 13 servers that are at the very top of this pyramid. So if you think of all the computers in the world and that pyramid feeding into it, there are 13 what we call authoritative servers at the top that contain that information. Very rarely do we actually interact with them. That's kind of weird, because we start piling all this information in, and we'll show you how that works. But as a thought, these are one of the most highly targeted spots in the world. There's only 13 of these servers across the entire globe. If I were able to control one or more of those, I could redirect all the traffic for, say, Amazon, because when a computer starts asking for what's Amazon's address, and that name trickles down, I could actually control the traffic going into Amazon. If I could control that traffic, I could reroute it then to my own site that looks like Amazon, but isn't, and get your credit card numbers or something else out of that. So these are highly prized targets at the very top of this namespace. So we call them name servers. And when we say hierarchical, that means they go from lowest to greatest. So all these organizations, so Peru maintains it. I maintain my own in here, a DNS server. And so as it discovers information, it builds up a database of things that it uses. So when I ask for Amazon.com, it goes to my server and it says, oh, I've already had that information before. It can send it back really, really quickly. So when we go to somewhere we don't know, that's when we start to doing that. So what it does is it keeps a list of IP address and a name and says, those two are connected, and I see that list. So those name servers, so they call them a lot of different, so they call them primary and secondary and forwarding. So generally you're going to see that your computer has two listed, a primary and a secondary. So in other words, if it can't contact the primary DNS, it'll contact another one. So on something like our school campus, there's multiple computers serving as DNS servers. So all of these tend to exist on our network together. We can use public DNS information. So Google has one that we can use and gets used quite a bit. So this is maybe a little better example of how this would work. So those name servers go from root level to top level domain, and then finally again up at the top, there's 13 of those root servers in the entire world. So if I don't know the answer to a question here, so I'm looking for, posttoasties.com or something, I don't know it here on my own network, I go outside of my network to a DNS server. If they don't know it, they go to a more authoritative one from their ISP or up the chain. And finally, if nobody else knows it, then it's at that DNS root level. So this is the fact that it works as well as it does is kind of amazing. But it starts at your local computer, goes to your local server, and moves on up. And we'll take a look and see what we're talking about there with that. So you may think of it this way as another way to do it. So here our local computer didn't know what the name is, so it goes to the local name server, so server in the closet. That server in the closet doesn't know it, so it goes up the stream. And finally it has to go up and comes back down into our query. So it's a hierarchical process, and it moves from lowest to highest. In fact, when they first developed the internet, they didn't have this idea of DNS out there. The only way we knew anything was you kept what was called a host file on your own computer. So your own computer had a flat file, wasn't even really a database, it's just a flat file. And that flat file said, here's an address and here's a name associated with it. You can still do something a little weird, because you can actually change that host file in your own computer. Now, Secure Sockets has changed it a little bit, but if you know somebody who's going to just a normal site that's not a secure site, for example, you can alter that host file really easily, and instead of going to google.com, you could send them to yahoo.com. Because the first place it looks is that Windows host file. Or on Linux, there's a host file. So it looks locally first. Most of us don't even maintain that anymore. So on my own computer, if I want to see what I'm talking about here, so if I hit the Windows key and CMD, all right, so I'm going to do my ipconfig again, /all. And the all gives me a lot of information up here. And I have to find the right adapter. So this is the physical adapter that's actually being used, not a virtual one. So here we have our IP address. Here we have our subnet mask we've talked about. This is that gateway. In other words, where it goes to get information about the world. But down here are these DNS servers. So the computer has a primary and a secondary. So the primary address it looks for first is it goes to 180.5, which happens to be a Windows server hiding in the back. If my Windows server doesn't know it, it actually asks the campus server. This is actually that router, and it, unfortunately, in this case, doesn't know a whole lot. All it knows is to forward that request on. So it doesn't get used a whole lot, and I probably should change that a little bit. But those are our primary and secondary DNS. If you look on your own computer, you can figure out what those are, because your computer will also have pulled up something similar to that. And it will, in here, they should all be the same. On your own computer at home, you may find you're routing to different ones. One of the most common ones we route to are things like a Google DNS. And Google DNS is really easy to remember because it's 8.8.8.8 and 4.4.4.4. So that gives us an ability to ask Google directly, where does something land? And sometimes that's a little quicker than doing our own. The downside of that is it means those requests leave your facility before they ever get answered. So DNS stores a lot of information. So those DNS databases out there don't just store that list of name, because there's a lot of different types of names. So there's an A record. There is the 4A record for type A or IP6. A mechanical name. There's a pointer record. Name server. So who's the name server for a domain? Mail exchange, which is pretty important. So how we get our email. And you may find that some of those are different when we look at them. There's other service records. There's other things that you can have in there. So how do I access that record myself and kind of see what things might be in there? So I'm going to go into Chrome really quickly. And I'm going to use my friend. This isn't going to show us everything, but it will show us a few pieces of it. So I'm going to do something called a whois. And I don't want to do it at GoDaddy. Let's do whois.net. So if I type here, this is actually querying that DNS server for me, and it's looking up who has that particular registration. Interesting, normally it pops right up. Hello? Weird. Maybe whois.net is having a problem today. Let's try. See if it goes any further. Okay, so there, the first thing you notice it says is Google's already registered. Well, that's good. And here it's got a lot of information about this company. Now, Google's not going to reveal you everything about their particular organization, but it will sometimes give you some information about who to contact. If there's an issue with them, who do I contact? Who's the technical representative that's supposed to be in charge of that? So let's see if my one for Peru has popped up. Aha, there we go. So here, I can see a couple of things. Now, other sites will pull up a little more information, but it says we were registered through EDUCAUSE. So we apparently go through some group that registers for us. It says our name server, where that's found, dns1.documents.state.ne.us. So in other words, the state has a name server for us. And then we have one on our campus, nameserver.peru.edu. And so sometimes you can find a lot of information out about a company. These two don't have a lot that they're going to reveal about you. But if I did, go backwards if I can find the mark. So if I did a whois for me, see if this one will show anything. So this will tell you a little bit about this domain. So it says, all right, he's using Ionis which is a web server host. It used to be called 1&1 out of Germany and Kansas City. So sometimes it'll, depending on which one you pull, it'll actually show information about where it's coming from. It'll have my technical contact and phone number and all kinds of stuff in there. So most places now hide as much of that information as possible, but your server still goes out and finds those A names, those C names, those MX records for mail, because sometimes we host them in multiple locations. So we may have peru.edu. The website may go to a server here on our campus. The email itself is hosted somewhere else, probably in Seattle or somewhere. And so it's got a different record. So it's got to point that record, the place, depending on what type of traffic it is. So in this case, even though Brad Griffin Consulting is existing, the email addresses are actually registered through another company called Hostway. And so my MX record and my A record are completely different, vastly different in most cases. So 90% of the world out there, when we talk about the internet, really lives on Linux or Unix style machines. Bind is actually kind of that idea of it's a piece of that Linux, it's open source, that software is free and available, and that's where probably 90% of those DNS servers actually live, is out in that Unix world. It's free. I can build them. It runs for years. I don't have to worry about Windows updates. There is a DNS service in Microsoft, and it works fairly well. But anything like Microsoft, we don't have that longevity that we do with a Unix system. Unix systems just run. They tend to be, by default, a little more secure. So typically we have, on the outside face, we'll have a bind server, or we'll externally use a Linux machine. Internally, we use a lot of Microsoft machines. So when we talk about Active Directory and all those, they access and use that DNS service really, really nicely. So a couple of really quick things that make sense. Internal and external queries, different DNS servers. I don't want anybody to see my internal DNS because they shouldn't need to know where every local computer is. And on my external, I keep out. So there's a block, there's a firewall somewhere between my external servers and my internal servers. Microsoft has made some products to make that very difficult. So in fact, in this lab, and we need to update and get rid of it, we just haven't found the time to do it, we're running a product that they had where Microsoft said, we're going to do everything. It was called Small Business Server. It was the worst idea they've ever had. I used it in here because it was quick and easy to deploy, and I had a license for it. But Small Business Server had all your internal and all your external all on one machine. Bad idea. You want to have some way between there. The other term you may see a lot is something called a DMZ, or demilitarized zone. And that is an area between two firewalls, some area that we can allow them free, unfettered access to the internet, but we also don't allow them into our internal network. So in other words, we put it, and maybe this makes more sense. So here's our internet out here. We have a hardware firewall. We have our external DNS then, another firewall, and our internal DNS. So it sounds like a lot of equipment to have to get out there, right? It's, again, we're basing this all on how do we best protect our network, and how do we best protect that data that's stored inside of there. So this system all works great until it doesn't. And so one of the things I want to look at is how do we find issues and how do we fix them? One of the best ways we do it on a Windows machine is there's something called Event Viewer. An Event Viewer, inside of Windows, everything we do is tracked. Everything program that starts, stops, services. When there is a problem, we can actually use Event Viewer and we can find those problems. So in this case, it says there's a printer spooler error. And so we can use this to track. So if I need to troubleshoot something has gone wrong, these Event Viewer logs are one of the first things we look at to try to figure out, is something logged in Windows that says we're going to have an issue. Linux has some other kinds of logs. Honestly, the Linux logs aren't as great as this, but things break less. So I don't know which way is better. But the Windows logs, the other way we use them, weirdly, is forensically. I can tell that you uninstalled software on your computer. So we walk into your office and you go, did you install Windows Flight Simulator and you were playing Flight Simulator all weekend long? No. Huh. You mean right here where you installed it and then you uninstalled it last night? So you can also use it to pull a lot of information about that computer forensically. Everything that happens on that computer is logged in here. So we also have quite a few command line tools. And so I want to get you guys comfortable with those. So one of the things I'm hoping we can do is experiment with some of them. Some of them you guys have already done. We've done a ping, but we have some additional ping tools we can show you. ipconfig. It's one of them when I sit down on a computer and I want to find out information. I hit ipconfig and I find out what's on there. NSLOOKUP, I don't use quite as often, but it's still a really handy tool and we'll take a look at it. So ping stands for Packet Internet Groper. That sounds like some kind of trivia question, right? Packet Internet Groper. So it's almost always installed on a Windows machine. Very rarely is it not in there. So that ping sets out and sends a little packet. And what it does is it sends it to the device we're saying and says, I'm asking for a response. If I don't get a response, then it times out. It's a great tool to find out if the other person is alive. So when I get on a network and they've told me, hey, you've got a server at a specific address, and I go, I can't seem to get it to respond. I don't have any other, let me ping it and see if it's at least responding that way. Or if I try to find a printer, I can use that ping to do that. So the way it works is something called ICMP, Internet Control Message Protocol. So it's a language that says, hey, you're going to send out data. Well, pings can be used for a lot of other things. So there's really two things that it does. So pings can also be used on a Windows IPv6 machine. So ping 6 doesn't work unless we're running IPv6, but it is a tool that's out there and it's available. So our book has some great tools, but it's easier if we actually do some of this and you can see what we have going on. So if I do a Windows key and do CMD, and then I do, let me move that over again. So if I want to find out the IP address of something, I can actually do it this way. So I can do ping www.google.com. So it pings Google, so that's one piece. But the other piece it does is it tells me if my DNS servers are working. So I can use it for a couple of reasons. I know that www.google.com, hey, I got a result. It knows what that address is. Internally, or if I know the address, I can actually ping it this way. So this is our web server that's back there. So I pinged internally, and notice the difference in time. So here, it took 19 milliseconds. Here, it took less than 1 millisecond. That's due to that difference in geography. And if we ping something in Germany, for example, it's going to take even longer because of that. The other number I want you to see out here is notice it's got something called TTL 19. This one's got TTL 128. From your reading, what does TTL mean? Has anybody found that in there? So TTL stands for time to live. So this is a little macabre. When we send out that packet, we're saying it's got a specific life. It can hit, in this case, it can have 128 jumps. So when I normally send it out, it can have 128 jumps. In other words, it can hit 128 routers along the way before it dies on its own. So it's got a specific time before it dies. Up here at the top one on Google, notice the time to live when I got that message back was 119. So that means it hit 9 routers between here and Google. So 9 times did it touch routers. So it left my router here. It hit the router at our campus, hit the router at UNL, and then 6 other routers before it got to the correct location to Google, and Google sent it back and said, hey, it's time to live, because each time that router, it modifies that packet and drops off a number off of there. So that time to live becomes kind of important. It can tell us a lot of things. Our time can tell us a lot of things. So here locally, if I'm less than 1 millisecond, that's probably really good. 19 milliseconds. But if I suddenly go from less than 1 to a couple hundred milliseconds, I might have a connection issue of some sort. And so I need to check that out and see what is going on my network. So it gives us a lot of information packed in there. And that time to live actually is the basis for another tool that we haven't talked about yet, and our book doesn't yet. So I'm going to show you bonus tool number 1 here. So let me scroll up a little bit here. So see if I can make this smaller so it's up and closer to the middle of the screen. Okay. There, I can see it at the top of the screen. Okay. So, I hit the wrong one again. All right. Another little shortcut is if you hit the up arrow key, the last commands you have are all stored in there. So I can just keep hitting up and down, and I can get to the last commands I had. Well, I don't want any of those. I'm going to start a brand new command that we have not seen yet. And that command is called traceroute. T-R-A-C-E-R-T. Traceroute. Why do we spell out one word, shortcut the other? I don't know. But traceroute does something kind of unique. So if I hit Google, this actually, using those time to live packets, kind of gives me an idea of where this packet is going to get to Google. So what it does, I said each time it hits a router, that TTL goes down 1. Well, what also happens, what we haven't talked about yet, are those packets report back when they die. So if I send out a packet with a TTL of 1 preset in it, the first time it hits a router, it dies, and the router sends a message back, says, hey, your packet died here. I then send it out with a TTL of 2. So it hits 1 router, 2 routers, and on that second router it dies. Then I send it out with 3 and 4. And the way it's normally set up is all the way to 30 hops. So we can go all the way to 30 hops. So what this shows me then is where those packets all died. So I can kind of form a route and figure out where some of those are. A hop is every time it hits a router. So in this case, it took 8 hops to get to google.com. And it died at each one of those locations, and we increased the TTL and sent another packet. So this isn't the only way that data can get there, because one of the advantages of IP traffic is it can go multiple ways. Typically, they go the same path. So this is a typical path that this packet would take to get there. And so eventually it ends up at some kind of indescript number that we don't understand with Google. and it ends up there. So it took 8 paths. So if we had a value for something weird, so let's do another one, and I can just pop up. Let's go to Sam's Club. Let's see if it will even respond. And it may not. So there are some companies that don't. So now we're getting some more information. So here we start that first one, that 192.168.180.1. That's my router back here. 10.20.208.254 is the college's router, one of them. I think the 192 is also the college's router. The 184 is UNL's. And then it gets into, I believe that's level 3 traffic there, Core 1, Omaha 1. And then as you see, it goes through some of that traffic and eventually ends up somewhere at a Kaimi Technologies. Didn't go to Sam Club though, did it? Interesting. But that's another tool we can use to try to figure out why our traffic is getting nowhere. So we can use the ping. The ping has some advantages. One of the things we can do with the ping, I think my connection to my server is a little flaky. And I want to prove that. And so I'm going to go back to ping. And I'm going to add another command. I'm going to put a -t at the end of it. And when I hit -t, notice what it does. Normally it would stop at 4 packets. -t says that you're going to continue to send pings to that server forever. That server, because it's set up to respond to pings, that takes a little bit of resources from that web server. So if I wanted to weaponize this idea of a ping, how many of you have heard of a distributed denial of service attack, a DDoS attack? How many of you have heard of somebody getting their website taken off the web? Yeah. Well, this is one way we can do that. My one computer is not going to knock down my web server down there. And in fact, we've tried it with all 32. That's not enough. But if I had managed to control 1,000 or a couple thousand computers and I got them all to send pings at the same time, that could be pretty horrible because they have to respond to that. So you're blocking legitimate traffic while it's responding to all these ping requests. So you can flood a computer with those. So in this case, what I'm doing is I will sometimes do this to a server or to another computer because what I'm trying to look for is, do I suddenly stop? Does it suddenly go from 1 millisecond to hundreds and hundreds? Is there something going on in this connection between my computer and that ping? So pings are a great troubleshooting technology. And it uses that command line. So if nothing else, you want to be the nerdy person in the office that they all respect and love because, hey, you got the skills to type stuff on a black screen. This is one of the tools we use all the time. We can figure out a lot of information with it. So the way I stop that, well, I can just close the window. That's one way. A little cleaner way is I can just do Control-C, and then it just breaks that. And so here it would actually tell me it sent 123, it received 123, and it lost 0, which is what we hope for, that none of those packets got lost. If packets are getting lost or that time starts growing and growing, then we probably have maybe a switch bad or a piece of wiring bad or a network card bad. So this is a great tool that we can figure out a little bit of information. So ping and trace route. I'm going to close that out of my way here. So there's a ping. Ping 6 is the way to do it over an IPv6 account. There is a lot of things inside of ipconfig, and we have just started to touch on them. There are some other ones we're going to do later on. We're going to show you how you can reset network connections and flush DNS and all kinds of things with it. So ipconfig all shows more. You have to make sure you're on the correct host, though. So we can pull that MAC address in there, which is pretty common, because we want to figure out a little more information. If I'm on a Linux machine or I happen to be on a Mac, you can actually open the terminal editor and do the if config. Works very similarly. So there's an if config, but at the heart of a Mac, part of the reason it's considered a little more secure is it's really running a BSD core or a Linux style core. And you can open up that terminal and you can actually run the same stuff here. So this is what it looks like. So it looks different, but it gets essentially the same information. So namespace lookup, NS lookup. So that's how we can figure out if that DNS inside is working also, because we can look up specific names or we can look up a specific address. So inside of here, so here we have, we're going to try to find out what Google, so NS lookup Cengage says, hey, I had to go to Google, public DNS. The address was 8.8.8.8, and I think it's this address. I go the opposite direction. This is a very similar thing called dig. And so Linux and Mac have this version. So we can also do that, and we can type CMD again. And you can see what the NS lookup looks like. So default server, if I just hit enter, it says, oh, yep, I should be going to spslabserver.spslab.local, and that's its address. So if I actually type NS lookup, now I'm going backwards, and it goes, oh no, I don't have it set up quite right. What it should tell me, you would think, is that 192.168.180.5 should resolve and tell me that it's SPS lab server, but I don't actually have something configured right. Oops. So it actually will sometimes give you some additional information. But you can do that with anything if you wanted to. So here it would tell me that here's where UNL's server lands. Here's some of its addresses. You notice there's more than one. Aliases. And there's actually probably more information, but it timed out before it got there. So again, there's a lot of tools out there that we have. One of the weird issues we have, and it has to do with how we're very secure or trying to be very secure, is if the time is wrong on your computer, you may end up with an error. So if you're curious, and I don't want to do it right here, right now, because it'll probably be an issue, but if you decide to go in and change the time on your computer, and you change it to a month ago or a month ahead, either one, and you try to go to almost any secure site like your bank, some of the Google sites, Google Mail, it's going to error out and say you can't do that because you have a security mismatch. We use time as part of that consideration. So if your time is off, so there is a command line prompt to figure out where your time is coming from. Honestly, I usually just go in and reset it in the GUI when I see that. But it's one thing to look at. If you suddenly see a weird error, look and make sure the time's not wrong. What that usually means on a desktop, there is a small little battery in there on a desktop, and after a couple years, that battery will die. When that battery dies, all of a sudden it won't hold time if it gets disconnected from power, and so you'll end up with a lot of these weird issues like that. I think I used to have, let me see if I have them in here anymore. Try the first drawer. And apparently we used them all. I did have some of those little button batteries so you could show you, but they're those, they look about the size of a quarter. They're about the same size as the ones you find inside your car remotes, but it's inside your computer. Your laptops also have them, The advantage to the laptop and why they don't die as quickly is it's generally got this big battery that's got charge. But even on a laptop, if you let it die and let it set for a month, you may find that you need to resync your clock. DHCP issues. So I can use some of the tools we have to see if I'm getting an address. My computer's really dumb on the network to start with. If I get an address, so if I do a IP config all, and my address is that IPA address, 169 something, I know I'm not getting a DHCP response. And so then I need to do a little checking. Is that DHCP server running? Do I have enough spots for it? So in this lab, we have a DHCP server, and we've got a pool of addresses. If we exceed that size and you ask for an address and all of them are assigned, that DHCP server says, nope, I don't have an address for you, and boom, I get that 169 address, which is kind of a useful tool. So one of the things we do a lot of times on a big network, instead of having multi-day leases, we have multi-hour leases. So those leases expire. So you got a request for an IP address, but it expires fairly quickly so it can recycle a little quicker. So what else do we have? That net mask, especially when we have to hand type it, tends to get us into trouble because we end up in the wrong collision domain. Gateway, if you put that in wrong, or even worse, and this is why we almost always use DHCP in a pool, is if I try to hand type in those addresses, I could set up all these statically, but we're not really good at that. And so I end up with two addresses that are the same. They have to be unique, and neither computer is actually going to work at that point. So, other things you might have to, if it's set up statically, make sure it's got the right information. Sometimes we set them up statically to test things, and maybe it doesn't change, or that computer got moved and now it's on a different network. Try recycling your DHCP. Turn it back on, turn it off, and we'll actually show you the command lines to do that. All right, so make sure there's a lot of information in this stuff this week, guys. So make sure you've read through it. There is a couple of videos I've put in there. So make sure you watch the videos. So there's a network addressing and some binary. We're going to have to dive a little bit into binary, and I know that's scary. So I'll try to figure out how I can do that, because I don't have a draw on the screen tool in here, so I've got to find one, because it's much easier for me to draw. I thought I could use the webcam, but apparently our webcam has now wandered out the door again. We have to understand binary. Binary is easy, though, because all of us can multiply by 2, right? I hope. Yep, perfect. You guys can all do binary. So we're going to show you how you convert from binary to decimal, decimal to binary, and how easy it actually is. And this is where Michael needs to come back in, because he's finding out he uses it more than you think, right? So it's one of those you go, man, I am never going to use this, and then later on you go, son of a gun. I maybe am going to have to use some of these things. All right, so there is a discussion board this week. Make sure you have done that. I will probably, it depends on my dad, like I said, had been in the hospital, so I'm not sure what my schedule is going to be this week. It's a little crazy. Next week, I will try to run through live in here doing the Wireshark, so lab simulation 1, so actually see how it works. The labs, the simulations are going good. My understanding is we have to have a little patience sometimes with the live labs, that they are apparently under-resourced. Supposedly they had put a lot more servers in. I don't know if that's the case. So if you run into an issue, and hopefully you've been working on them for the last week and a half, but it gets down to Sunday and you still haven't finished that, send me an email and I can probably extend that, and I won't really get too excited about it because I know that they're having issues. And Sunday, apparently everybody in the United States comes in to do homework, and you'll get a message that says, this server is not available at this time. So if you can do things at a time that every other college student doesn't in the world, that's kind of helpful. But Cengage is supposedly increasing the number they have in there. So I have put in there also, there is at the very bottom this binary and IP addressing video. I would encourage you to go watch it. If you came in here to the physical seat today, if you would log in, please, and just post your seat number, just for that horrible contact tracing thing, so that we can hopefully at some point get rid of this darn COVID-19 problem. I think we're all in agreement on that one, right? I hope so. I hope so. Or at least come up with a test where they don't have to shove the swab all the way through the back of your head. If you find anybody that says they enjoy getting the COVID testing, we really need to probably have them looked at. It's not the worst thing in the world, but it's certainly not the most pleasant either. So if you will do those two, and then make sure you do the discussion boards, everything that is due has a link in here. So the quiz is due, and then the 2 simulations and the lab that is in there. The review is actually a great review, does not generate any points. Don't skip it because it will help you. In fact, what I noticed is about half the questions on there are also the same ones as on the quiz. Trying to make life good for everybody. All right, any questions? What is in a packet? So when we talk about a data packet, and we explore that, give me about 2 weeks, and we explore exactly how those zeros and ones, when we do the Wireshark next week, now you'll do a simulation on how to install it and see it, but when we do it here, we'll try to explain and show you a little better what a packet of data actually is. It's really just a group of zeros and ones that we know is got a beginning and an ending, and how do we find those beginning and endings. So that's really, when we say packet-based technologies, that's really what we're meaning. We're breaking things up into a chunk of zeros and ones. All of your phone calls now in the United States, that's how they're done. They're not analog anymore. It's all broken down into packet-based technologies and how that gets sent across the U.S. All right, any other questions? Anybody amazed that I got through all that in this amount of time? Yes, me too, because I was not planning on it. I didn't figure we'd do that. All right, let me hit the stop button here real quick.